Write the output of the statement given below. So you are provided with a program and you need to write the output of this program. Whenever you write the output of a program, the first thing to be borne in mind is memory should be allocated for all the global variables. And a global variable means above the main function and outside all functions. If there is a variable, the variable is known as a global variable. So above the main function and outside all functions, here there is no variable. So program does not contain a global variable because this one is a function and this is a structure, a data type created using structure. So above the main function and outside all functions there are no variables. So this program does not contain a global variable. Now to answer an output type of question, the second point to be borne in mind is execution of a C++ program starts at the main function and it ends in the main function. It ends here. So execution of a C++ program starts here and it ends here. The first line inside the main function. My box is a data type created using structure. B1 is a variable of the data type or B1 is a structure variable. So memory should be allocated for the structure variable B1 and memory is allocated as follows. Name of the memory location, the content of the memory location and some address. Now the content area is divided into three parts because this data type consists of three members L, B and H. So this content area is divided into three parts. The three parts are as follows. B1.L because the first member is L. The second one B1.B because the second member for structure my box is B, and the third one B1.H because the third member is H. So memory should be allocated for the structure variable B1. Now after allocating memory, this initial value comes in the memory location. And how does the initial value appear in this memory location? The first initial value comes in the first memory location. The second initial value comes in the second memory location. The third initial value is not given, so by default the third initial value is 0. So the initial values appear here. The first initial value 10, that is the first one appears in the first memory location. The second one appears in the second memory location. The third initial value is not given, so by default the third initial value is 0. A point to be noted is if any one initial value is missing, by default it contains 0. Suppose the last two initial values are not given, then by default the last two memory locations contain 0. And if no initial value is given, the memory locations contain garbage value. So for 0 to appear in a memory location, at least one initial value must be given. Only then 0 will appear in the remaining memory locations. So please make a note of that one. If any one initial value is missing, by default it contains 0. And for 0 to appear in a memory location, at least one initial value must be given. If no initial value is given, if the initial values are not given, then the memory locations contain garbage value. Similarly, memory should be allocated for B2 and B3. So this is how memory is allocated for B2 and similarly memory is allocated for B3. So this line is completely executed. After executing this line, control goes to the next line. Now here there is only one operator plus plus. So only when multiple operators are there, we need to apply precedence rule or the priority rule. Since there is only one operator, you can simply execute this. So your b1.h contains 0 and plus plus b1.h means this 0 will become 1. You can see this 0 becomes 1. Now this is completely executed. Control goes to next line. When you see this symbol, understand that it is a function. On encountering a function call, finally control reaches the point where the function is defined. So from here, finally the control reaches here. Now the first argument is passed to first parameter, second argument is passed to second parameter, and here the third argument is not given. So by default, this default value appears in the third parameter. And suppose if the third argument was also given, say for example the third argument is 5, then that 5 appears in the third parameter. So please make a note of this one. First argument is passed to first parameter. Second argument is passed to second parameter. The third argument is not given. So default value appears in the third parameter. So B1 should be passed to M1. Now here there is no ampersand sign. Ampersand sign is not given, which means your M1 is an ordinary variable and a new memory should be allocated for M1 like this. Now the values of B1 should be passed to M1. Your B1 contains 10, 15, 1. So this M1 contains 10, 15, 1. 10, 15, 1. Now the second argument should be passed to second parameter. Because of this ampersand sign, M2 is a reference variable. So new memory should not be allocated for M2. New memory should not be allocated for M2. Instead, M2 is another name for B2. So this B2 gets one more name. It is M2. Like this. Now the third argument is not given, so default value comes in the third parameter. So let me allocate memory for this parameter as follows. And here the default value comes. The default value is 10. So from here, finally the control comes here, and first argument has been passed to first parameter, second argument has been passed to second parameter, and the default value came here. Now let me go inside the function. The first line of the function. This one is a postfix operator because operator comes after the variable name. The rule of postfix is use and change. Use and change, which means m1.l should be used for assignment operator, that is m1.l should be assigned to m2.l, after that m1.l++. I repeat, it's a postfix operator because operator comes after the variable name. So use and change, postfix operator, use and change, meaning m1.l should be assigned to m2.l. Let me do that first. So this is m1.l. That should be assigned to m2.l. So this is m2.l, which means this 10 should be assigned here. Yes, done. Now after that m1 dot l plus plus. So 10 plus plus, this should become 11. It becomes 11. Now the next statement. Here multiple operators are there because assignment operator is one operator and this is the second operator. Multiple operators are there, so you need to apply priority rule, the precedence rule. Now this one is a prefix operator because operator comes before the variable name. So what is the rule of prefix? Change and use. Change and use. So first let me change m1 dot b plus plus m1 dot b. So this is m1 dot b plus plus 15, that becomes 16. Now the changed quantity, which is 16, should be assigned it to m2 dot b. So this is m2 dot b. So your 16 comes here. This 16, it comes here. So 16 comes here. Now the third statement, this one. Here multiple operators are there because assignment operator is one operator, postfix operator is the second one. Now what is the rule of postfix? Use and change, which means counter should be used for assignment operator. After that, counter plus plus. So let me use it. Counter should be used for assignment operator, which means counter should be assigned to m2.h. Your counter contains 10. This is m2.h. So here 10 comes. Here 10 comes. Now after that, counter plus plus. So this becomes 11. You can see this becomes 11. Now here you get the first line of answer. It is m2.l space m2.b space m2.h and endl. So here it is 10 space 16 space 10 and end l means the cursor should go to next line. So your first line of answer is 10 16 10 and because of end l the cursor went to next line. Now this function is completely executed. After executing a function, control goes to the point from where the function was called. So control comes back here. Now when the control comes back here, point to remember the names m1, m2 and counter does not exist. So these variable names does not exist. So let me do it. So these variable names does not exist. Okay. Now this has been completely executed. So control will go to next line. Now here you get the second line of answer. b2.l space b2.b space b2.h endl, and this is b2.l, b2.b and b2.h. So 10 16 10 endl. So here you get the next line of answer 10 16 10 and end l means cursor will go to next line. Now after executing this, control goes to next line. Now this is assignment operator, meaning right hand side will be assigned to left hand side, which means B1 will be assigned to B3. So this is B1 that will be assigned to B3. So 10 15 1 comes here. You can see that 10 15 1 comes. Now after executing this, again the control will go to next line. Now the first statement plus plus b3 dot l. Here there is only one operator, so no need to apply any precedence rule. Simply do it. So this is b3 dot l. So plus plus 10. This becomes 11. You can see this becomes 11. Now here also there is only one operator, so no need to apply any rule. Simply execute this one. B3 dot B plus plus. So 15 plus plus, this becomes 16. It became 16. Now plus equal to is a short form in C++. It can be expanded like this. Now A plus equal to B means A is equal to A plus B. So B3 dot H plus equal to 5 can be expanded as B3 dot H equals B3 dot H plus 5. So this one should be executed using this expanded form. Now assignment operator means right hand side is assigned to left hand side. So what is right hand side? B3 dot H, it is 1. This one 1. So B3 dot H is 1 plus 5. So 1 plus 5 6. So 6 is assigned to B3 dot H, which means this becomes 6. Now after executing this, control will go to next line. Now as I told you, when you see this symbol, understand that it is a function. On encountering a function call, finally control reaches a point where the function is defined. Now the first argument is passed to first parameter. So here ampersand sign is not there, which means this is an ordinary variable and a new memory should be allocated for M1. So like this, new memory is allocated for M1. Now B3 should be passed to M1. So what is B3? 11, 16, 6. So this becomes 11, 16, 6. Now the second argument is passed to second parameter. But because of this ampersand sign, this one is a reference variable. So new memory should not be allocated for M2. Instead, M2 is another name for B1. So this B1 gets one more name, which is nothing but M2. This one, M2. Now here the third argument is given. So third argument is passed to the third parameter. So new memory should be allocated for this one. Let me allocate new memory for counter. Yes, the new memory is allocated and the third argument is given. So third argument comes here. You can see the third argument comes here. Now inside the function, the first line, multiple operators are there, assignment operator and postfix. So you should apply precedence rule. What is the rule of postfix? Use and change, which means m1.l should be assigned to m2.l first. So which is m1.l? 11. That should be assigned to m2.l. So this is m2.l, which means this 11 should come here first. You can see 11 comes there. Now after that m1.l plus plus, so this must become 12. You can see it became 12. Now the second statement, here also multiple operators are there, assignment and prefix. What is the rule of prefix? Change and use. So first I need to change it, plus plus b1 m1 dot b. So plus plus 16, this must become 17. Now the changed value, which is 17, should be assigned to m2 dot b. So this is m2, this is m2 dot b. So this 17 should come here. You can see the 17 came there. Now here also multiple operators are there because assignment operator and postfix. What is the rule of postfix? Use and change, meaning first counter should be assigned to m2.h. So counter contains 5. This is m2.h. So this 5 should be assigned here. Yes, 5 assigned here. Now after that, counter plus plus. So counter plus plus means this 5 should become 6. Yes, it became 6. Now here you get the next line of answer, m2.l space m2.b space m2.h and endl. So this is m2, 11, 11, 17, 5. So here you get the next line of answer, it is 11, 17, 5. And because of end L, cursor goes to next line. Now after executing a function, control goes to the point from where the function was called. So control comes back here. Now when the control comes back here, don't forget the variable names m1, m2 and counter does not exist. So these variable names does not exist. So let me delete the variable names. Yeah, it is deleted. Variable names does not exist. Now after this, control goes to next line. So here you get the next line of answer, b3.l space b3.b space b3.h and endl. So the next line of answer is 11, 16, 6. And because of end L, cursor goes to next line. Now again after this, control goes to next line. The first statement, plus equal to is a short form. How do you expand that? Like this, a plus equal to b means a is equal to a plus b. So b1 dot h plus equal to b3 dot h can be expanded as b1 dot h equals b1 dot h plus b3 dot h. Now assignment operator means right hand side should be assigned to left hand side. So what is b1 dot h plus b3 dot h? Your b1 dot h is 5, b3 dot h is 6. So 5 plus 6, 11. 5 plus 6, 11. That should be assigned it to b1 dot h, which means this b1 dot h contains 11. You can see that it contains 11. Now this is executed. Now the control goes to next line. Here multiple operators are there, assignment and prefix. So what's the rule of prefix? Change and use. So first minus minus b3 dot h, which means minus minus b3 dot h. This becomes 5. And the changed quantity, which is nothing but 5, should be assigned it to b1 dot b. So this b1 dot b, this is b1 dot b. So this 5 comes here. You can see it became 5. Now this is completely executed and now the control comes here. Here assignment operator is there, postfix is there. So rule of postfix, use and change, which means b3 dot h should be used for assignment operator. So b3 dot h should be assigned it to b1 dot h. So this is b3 dot h. This is the memory location b1 dot h. So 5 should be assigned here. Yes, 5 is assigned here. And after that b3 dot h plus plus. So this 5 should become 6. Now this is completely executed and the control goes to next line, the last line. Here you get the last line of answer, b1 dot l space b1 dot b space b1 dot h and endl. So b1 dot l, 11, 15, 5. So here you get the last line of answer, 11, 15, 5. And because of end l, the cursor goes to next line. Now after executing this, finally the control comes here and nothing more to be executed. So after this, control goes back to the operating system and the program terminates. So for the given program, the final output is this. this one.